Yeah.
Don't forget to like and subscribe. It's Jim Keller, everybody.
And today is September 26th. I am coming to you live from Lana'i Cat Sanctuary, where we have... Oh, they've all disappeared.
Aww.
They're all over there. Lana'i Cat Sanctuary for the once every 2-3 years that I'm here. It is very warm. It is in the early to mid 90s at 70% humidity, and it rained overnight. But we have cats. Oh, yes.
So I may not be at a cat sanctuary. I do have 2 cats though. They're downstairs.
I have 778. They have gone up from first time I came here. They were 550. Then they were 650, then 660, and I just saw the number as I came in. They're now at 778. In the last 3 years, they've put up all new fencing. They've got a couple new areas. They're still rehoming about 120 or so into mainland US. But then, because this is a big island in Hawaii, it's still full of feral cats. Would you like to say hello?
Just staring straight at the camera.
Yep. I've got a brand, even though I'm coming live through the laptop, I've got a brand new FX30 that I'm going to be taking lots of cat pictures.
Oh, nice.
For. Always got to have a stack of cat pictures.
Always.
That being said, it's this is the second one we've done since Hot Chips, second Poutine, and last one was pretty quick, and it was on the back of news that day. So there's like 6, 7, 8 weeks to get through. Yeah, if I'm trying to minimize wind noise. If it gets really bad, I think I can get out my other microphone or what have you. But yeah, we've got a lot to talk about. Full disclosure, I'm here for Qualcomm's event, not the Cat Sanctuary, but Hawaii. All my travel was paid for by Qualcomm, so disclosure in there. I haven't been commissioned to do any writing or anything, and currently out of contract with Qualcomm, but that's being renewed soon.
Nice.
So yeah. But for full disclosure, right before we get into the meat of it, because Qualcomm's had some really impressive announcements this week. That being said, we wish we had more information. But we are told it will come, which is a little bit weird because usually we get the information before we get the launch, so we can do it all in one.
Although they did kind of do this with Elite the first time. Yeah,
well, it's a Qualcomm thing to do stuff around this way. Yeah. Whereas Intel, AMD, typically
it's product launch. It's details first, product launch next. Yeah.
And even then,
and
there's an event here in Hawaii. There's also one in Beijing for the Chinese, because let's be honest, the 2 major markets are China and the US.
Yep.
So, and if anything, China's got to be bigger than the US at this point.
Yes, but also maybe
for flagship US.
Well, I'm thinking modems. Qualcomm modems are really big here in the US because iPhone, but they're making their own modems. So
but actually, which we covered in the previous Poutine.
But speaking of events, we're both going to be at. There's currently a ground hall in Phoenix, which is causing some issues with people flying in right now.
Yeah.
For ITT to.
Well, it's good that I can fly all this way and loop several events in.
Yep.
On Tuesday, we haven't yet formally announced it, but I will be at Altera's Innovator Day. I will be hosting the main live stream. I've actually got a video still to edit that has to go out before that.
And actually, on Tuesday night, I'll be hosting I'll be a co-host on the Craft Computing live stream, so you can catch me there.
It's all go, go, go.
Indeed.
So let's begin. Hello, everyone, and welcome to the Tech Poutine, the weekly-ish podcast from me and George, where we talk about processors and silicon and how we've taught special rocks to think in very special ways. We call the Tech Poutine because I run a channel that has potato in the name. George has a channel that has cheese in the name, and if we had a guest, I'm pretty sure this is the guest right now. Hello, you're gravy. You're making the poutine. Absolutely. And if we had a sponsor, this would put it. We don't, so go and check out. I don't sell this, but go check out Lana'i Cat Sanctuary and donate if you're that way inclined. You really want attention, don't you? So we do accept and read super chats made by our listeners and watchers, but only if they don't demonetize the channel. The show usually lasts a couple of hours. We probably do a shorter one just because I'm in a cat sanctuary and I'm already developing a rash because I'm scratching too much. But if we stick around, we'll hopefully get to some Q&A, but there's some pretty meaty topics to get into today. But first, today's question is, George, how are you doing?
I'm good, tired, lots of travel. As you know, actually sort of a topic zero, I was at AMD Austin ET for their first. They didn't really have a name for it, so I just called it the AMD Tech Day.
It was meant to be like a ROCm and AI software.
It was Instinct and ROCm focused. This is their first one, so I gave feedback about how one, it should be a multi-day event, and two, since the four big departments, you could say, of AMD are CPU, GPU, FPGA, and DPU/NICs. You should have like two of those in a tech day, and if you have,
but you forget with these big companies, each business unit might as well be a different company. On some level, they are so independent.
Sure,
but with system design now for machine learning, you have to do it together. Yeah, but no, you got that. Also, that event was the formal launch of ROCm 7.
Yep.
Anush was there. He gave the main presentation, didn't he?
Anush and Alan. Alan Smith, who I did an interview with. Apparently, that interview actually sparked a sort of an internal podcast similar to what, like, an interview, but sort of on a like deeper and more sort of NDA level within AMD itself. So, like, to inform other parts of the company what they're doing. So
it's half of what I do these days seems to be helping companies with internal comms. Right.
Internal comms are important.
It's when you tell somebody says, "Oh, I finally realized what the memory controller I've been designing was used for," inside their own company when they've seen part of my content, and you're like, you should know this. You should know this. But anyway, no, internal comms is always good. More information to the engineers so they know what it's going to.
So, the wind is quite strong. Maybe you should switch over to DJI's mics, Ian. But no, that was fun. If you want some more detail, go watch my video on it. Dom, if you could put the link in the chat, that would be great. It's the latest video for the Chips and Cheese YouTube channel. One thing that was technically addressed in that video is that Strix Halo now has support technically with the release of ROCm 6.4.4, which is newer than 7.0. Yeah, it's because of Windows stuff, as far as I understand it. It's because, it's they're still sorting that out. And come on, guys. I know you guys have been working hard, but it would be great if that was unified. But yeah, so and AMD Labs was great because they did actually show like their thermal and power testing and all that. It was really fun. But moving on to actually, I think I'm going to cover, or I'll start with what's technically topic 2, which was ARM had released their new C1 CPU cores last week, essentially, or 2 weeks ago. And they have now unveiled the new branding, which I'll be honest, I'm not a fan of. I don't like the C. Yes.
Is this better?
Yes, that's a lot better. That's so much better. Yep.
It turns out the dead cat helps.
Just a little bit, yeah.
In a cat sanctuary. I'm massively red. Jeez.
Are you having an allergic reaction?
I guess so, and I've only been here an hour. It's the key is to not scratch. So, yes, launched.
Yeah. So, ARM has effectively discontinued the Cortex brand.
No.
Well, it's disappeared.
No. The new product isn't. The new cores aren't called Cortex. They still have the old products that are still named Cortex.
Yes, but moving forward, Cortex is not being used anymore.
So
at least for this generation.
Instead of Cortex A925, A725, A520, we now have C1, C1 Ultra, C1 Premium, C1 Pro, and C1 Nano.
Yes, and then those will be put
in order.
CSS. So those cores will then be put into different CSS products. So,
the way ARM presented it is, we have a new compute subsystem for mobile called Lumex.
Yep.
It consists of the new C1 cores. It consists of new Mali graphics. Immortalis does not survive a second generation in terms of naming because Mali has all the brand identity. It also includes things like Scalable Matrix Extensions 2. This is ARM v9.3-A in the top and down design. And the first chip with it, with these cores, is the MediaTek Dimensity 9500. Which is coming out in the Oppo Find X9, the Vivo X300 Ultra, if I'm correct.
Yeah, in some markets, they have already come out. Some people already have devices.
Yes.
And we'll get to that in a bit. But
the key aspect here is C1 Ultra is the new premium core. It is the new Ultra core, not to be confused with the premium core. They've put a design. So classically, we had 925 and 725. They've put a new core in the middle of that,
an 825,
an 825, if you will. But this is what they've called the premium, or is this the pro?
This is the premium. So the C1 Ultra replaces the X925 and X9. Essentially, think of it as what would have been called the X930. The C1 Premium, what it is that it's the C1 Ultra, but with only 2 vector pipes instead of the 6 vector pipes that the C1 Ultra comes with. This was a configuration option in the X925 that you could have a cut down vector with. In the Premium, that's what the Ultra and the Premium are the same, barring the cut down vector. The C1 Pro is replacing the A725, or what would have been the A730, and then the successor to the A520 is the C1 Nano.
So, yeah, the lots of performance uplifts, as you might expect. ARM says that the Cortex X1, 5 years ago, from the first X series core to the new Cylene Ultra, is a 75% IPC increase. The premium compared to the Ultra is about 35% smaller in terms of die size for the same L2. And the Ultra is also 35% higher performance than the C1 Pro. So the idea is that you have this, you have the Ultra goes into flagships. So you get an Ultra plus, say, 2 Ultra cores plus 6 Pro cores. And then in the sub flagship, so the $600 devices rather than $1,000 devices, you get 2 premiums and 6 pros. Or maybe you get a 1 plus 3 plus 4 in it. There's a lot of potential for differentiation here.
And another choice of differentiation is actually the SME 2 units. So SME is not an in-core thing like Intel's AMX. What it is it actually hangs off the CMN fabric. So this is a cluster-wide unit, and you have essentially 2 options: a half-width unit or a full-width unit, which equates to a 4096-bit unit and a an 8192-bit unit.
So that's not how it was described to me at all in any way.
Right? That's how it is. That's, as far as I know, that's how it works.
So SME2, Scalable Matrix Extensions 2, is it's not a DMA device like a GPU. No. The way a GPU works is you fill an instruction queue and then submit it to the device. The way this works is it is direct instructions decoded by each core, and the core can then submit the instruction to a collective unit on the core, the SME2 engine, just like with Telum 2 and IBM's AI onboard processor. It's part of the ISA. It's part of the instruction set architecture. You know, a GPU is not part of the instruction set architecture.
It is part of the ISA. My point was that the actual unit is not a per core thing. It is a collectively shared unit within a cluster.
So it makes it different to an NPU, because an NPU is like a GPU. It's a DMA device with an instruction queue, instruction buffer that you fill. However, it acts like an NPU because it's a collective unit shared between cores. Now, the way ARM is marketing it is that the base design has 1 SME engine, but it can support up to 2. And they expect that nobody this generation is likely to use the 2 engine design.
2 engines sounds more like a server grade thing to me.
It's they said, well, in this case, it's just the mobile processor. Server gets Neoverse and what have you. And there'll be updates to Neoverse down the line based on these cores as well.
And mind you, SME is in conjunction with SVE, or Scalable Vector Extension. So those are complementary, not.
But a scalable vector engine is a per core.
Yes, that is per core. Think of it like an AVX unit.
So
Intel or AMD.
I mean, honestly, one of the criticisms ARM's laid at ARM's feet is you guys don't have your own NPU IP. They have Ethos, which is based for embedded, and that's like super low power. We're talking microwatts, milliwatts sort of thing.
I was about to bring that up, and it sounds like this is how they're sort of doing their matrix operations.
The way it was described to me is it's not going to be as efficient as an NPU because, as you say, it's attached to the CMN, but it's still part of the ISA. But think of it as a way to bring NPU-like processing to the CPU directly without needing to go to the GPU and the additional latency that the GPU would bring.
I will say, I actually think that if you're using it as an NPU, this actually makes a lot of sense as an NPU replacement, because NPUs are traditionally hard to program and aren't widely used because of that.
Yeah.
Because this is integrated into the ISA, this will actually be easier to utilize.
One, it's a first-class citizen. That being said, there will be designs with 0 SME units, and I think that is a little bit of an oversight, really. I think they should have made one minimum, because their response is, well, what if you get like a 2-core nano chip? A nano-based device is IoT. It doesn't need an SME unit, which is fair, but it does complicate things a little bit. That being said, one of the key architectural designs in ARM has been Neon. Neon's been in what, since ARM v6, ARM v7?
V7, I believe.
And is essentially a 128-bit vector unit. For lack of, you pack instructions in and compute.
128-bit SIMD unit.
Yeah. It has taken the best part of a decade to get Neon instructions to fall out of compilers with relative ease. As in, it's a lot easier than it used to be, because, like I said, all this used to be hand-coded, like every new ISA innovation is. But you typically shouldn't trust the compiler with vector code if you can help it, unless you have a really good compiler team and you can get it right. We're at a point now... You should
be using intrinsics to do it.
Yes, we're at a point now where a good chunk of the compiler stack can output Neon. With the hurdles aren't as big as they used to be. For something like this, we're again going to have to wait at least another 10 years before SME2 just pops out of normal code.
I hope not, but I wouldn't be surprised if that was the case.
But it does mean that if every ARM-based CPU that isn't Qualcomm's custom cores, that isn't Apple's custom cores, has, so basically every MediaTek and every Samsung built core as well, plus all the all the Spreadtrum and Unisoc and everything else, it does mean that there is now a potential for something that is as NPU-like but easier to program. The question that always comes up in these is, well, NPU fragmentation in the smartphone space, right? It's everybody has their own NPU, everybody has their own software stack. Is there a way to unify it? The answer is at the API level, not at the hardware level, though this is at least an attempt at the hardware level. Qualcomm's latest cores, which we'll get into in a bit, do not support SME2. I do believe they support SME1.
No, they do. They do support SME2.
Okay, I thought I overheard something that's saying whether they're SME1 only.
I don't know if it's just SME. It has SME instructions of some kind. Yeah.
Either way, these are updated core designs. ARM's big thing is that the nature of CSS has changed. The compute subsystem is how you license the core. If we go back to ARM's latest financial call, for example, they actually talked about how much their royalty rates are for using these cores. In a mobile phone context, the typical agreement with a V8 is 2.5% of the final selling price to a cap. V9 is 5%. First generation CSS was 10%, and this is going to be a bit more than 10%. So if you're buying a CSS phone for $400, $40 of that goes to ARM as part of the...
Probably more realistically 50 or 60, but yes.
But the reason why they can charge that is because these... normally you provide the IP in a form that isn't necessarily 100% qualified, but is part of the way there, and the chip designer will design around
each individual part is qualified, but the whole hasn't been qualified.
Things like MediaTek swapping out the L1 cache from a 6 transistor design to a 12 transistor design, you can still do that with the core IP. What this CSS is this generation is because they will happily provide what's called the GDS2, which means it's ready to go to the fab. You still need to add a few bits to it, like if you want an NPU or some of the I/O or a modem, because ARM doesn't provide those. In the same way that NVIDIA essentially supplies the GDS2 if you want an NVLink IP. It's a black box, it's an encrypted black box, and it's designed to, but we always say with chip design, the key metrics are power, performance, area, cost, and time to market. Because these companies want to put new chips in the market every year, or perhaps even every 8 months, that time to market is important. And what ARM is saying is, hey, give us a little bit more money per device, and we'll shave 4 months off because our design is already pre-optimized and ready to go. So yeah, that's their big thing. You can pick and choose some parts of the CSS that you want to or not, or just change from a CSS license back to a standard V9 license. If you want to do some other stuff. ARM's argument is that their main customers want performance and time to market. Customization, they're happy to do that with the rest of the core, or with some parts of the physical design, getting to 4.3 versus 4.6 gigahertz or such.
So Metalhead 2550, SME2 is in the ARM v8.8-A ISA spec. So there are, it is within the V8 spec.
Okay.
But so moving on so quickly, because we spent quite a bit of time on this. That's not the document I want. So looking at the changes from the Cortex X925 to the C1 Ultra. And a big thanks to, that's the wrong one.
Yeah.
There we go. Yep. Big thanks to Geekerwan, who has these devices and did micro benchmarking of the structure sizes. Now, I will say, small comment, there should be 6 FP units here for both of these cores. But otherwise, these look to be, as far as I'm aware, accurate. The major change in C1 Ultra, as you can see, is the ROB has increased massively, along with the physical register reclaim table, which, don't quote me on this, I believe is basically the amount of registers you can keep in flight at any given time, whereas the retired queue is the retired queue. They've also increased the FP and /SIMD units, or register file, from 370 entries to 560, along with buffing all of the schedule entries by a large amount in order to keep the flow of the processor going. However, what hasn't changed, and I find this interesting, is the integer register file. That has not changed in size. That is still 265 entries. Now, based on testing of Zen 5 that Chester has done at Chips and Cheese, I have a very sneaking suspicion that C1 Ultra is going to stall quite often on its integer register file, and that it may not actually have enough integer register file entries to feed this backend, based on what we saw with Zen 5, which has a similar 240 entries, but fewer ALUs, granted different ISA, but...
Have you pinged ARM about this yet?
No, I haven't. Frankly, I don't actually know who my ARM contact is supposed to be.
Yeah, I can make that connect. Yeah, I did see that register file decrease, and I thought, wait, what?
Not a decrease, barely a non-increase.
Yeah.
Right. And Metalhead, I believe the latest Apple cores are V8.8.
Oh, that's right. The
Or V8.9, one of those two.
yeah.
But yeah. So yeah, it's interesting. It's odd. The data cache has doubled, which is nice. But yeah, I have a sneaking suspicion that the integer register file is going to stall quite often. But moving on from there, the performance that Geekerwan saw on the C1 Ultra was not quite what ARM was quoting, nor did it actually match up with MediaTek's 4000 GB6 results. Geekerwan was seeing, I believe, 36 or 3700 in GB6 at about, at the 4.2 gigahertz that the Dimensity 9600 was clocked at. That's 94. That's a 95. Hold on.
Somehow half my images that I'd already uploaded to look at have gone, and some of them are mislabeled in the system. Huh. Yeah. Okay.
Anyway, yeah. So, and actually, speaking of those results, Qualcomm announced their third generation of Oryon core, along with the 8 Elite Gen5 Oryon, along with the 8 Elite Gen5, which is the successor to the 8 Elite. Bit confusing with the rename, but think of the 8 Elite as actually the 8 Gen 4, and then this is the 8 Elite Gen 5.
Right. So the way to think of it is, there are third gen Oryon cores in the mobile CPU, which is 8 Elite Gen 5, and the compute notebook CPU, the Snapdragon X2 Elite.
Yep.
What made it difficult here at the event a little bit is that when they were talking about the core, you have compute people here and you have smartphone people here, and sometimes never the twain shall meet. And so at an event, you've got people talking laptops and you've got people talking smartphones. And when somebody says, oh, yeah, no, that core can go up to 18 watts, you have to clarify, are you talking about the compute chip or are you talking about the smartphone chip?
So, now, Geekerwan did now, granted, he did say that he wasn't actually able to get it fully stable at the full 4.6 gigahertz clock speed, but he did actually measure.
You're talking about the mobile chip now.
Yes, the mobile chip.
So, yeah.
He did clock the mobile chip.
Let's keep reinforcing that we're talking about the mobile chip.
Mobile chip first. We'll talk about the SDXC 2 in a little bit. But for right now, if I say I mean the mobile CPU or the mobile SoC.
Yep.
The mobile SoC was clocked at a peak 1T of approximately 22 watts, including memory, for a single core in, I believe it was B Waves, which is a subtest of the spec 2017 FP tests.
It's 503 B Waves.
503.B Waves.
The issue with the way these news cores were described to me is, yes, they have very high peak frequencies. The idea is that these peak frequencies and peak power consumptions are meant to be more like 20 millisecond. Hello. I have a cat on my laptop now. This is what yeah, just wait until it escapes from all my Yeah,
changes out that. Yep.
so the peak frequency is meant to be literally for like button press acceleration,
Yes.
not for software acceleration. The idea is that when you have a button press, your CPU kicks into super high gear for milliseconds, perhaps even a frame. We're talking 16.6 milliseconds here before it then clocks down. The minute you go into full single-threaded workload, the point is the turbo frequency of a single-threaded workload isn't going to be 4.6,
no.
right?
However, in Geekbench, without LN2, because that's how he was able to get the results for spec on the phone, was using LN2 to keep the clock speed stable. Geekbench was only pulling about 9.9 watts on a single core and approximately 20 watts for the multi-core tests. Granted, Geekbench is a very short, like a very, very short test.
Yes.
However, I would like to sort of talk about how we've been seeing sort of increasing power as time has gone on in this form factor. And
that's because they're not meant to run at that frequency in real life.
No, but even NT, like we're seeing increasing power usage.
No,
right?
Okay. So take a 200-watt GPU from 10 years ago. If you measured the current draw and the power draw, you could say it peaked 600. Right? The transients gave you 600 watts power draw. Now, of course, is that sustained? No, it's literally for microseconds or milliseconds, right? So is it fair to say, well, actually, no, it draws 600 watts because we measured 600 watts once, or we use liquid nitrogen to keep it running at 600 watts? It's that sort of argument, and that it kind of annoys me here, right? The best thing that somebody like Geekerwan could do, honestly, is say, let's pick a power spec, like 6 watts for the core and 10 watts for the device, and let's limit it that way. And then what performance do we get? If you're gonna theoretically limit it to the peak frequency and use liquid nitrogen to get there, I'm not sure that's relevant for anyone except for overclockers, or to do some sort of circle jerk of numbers, just because, hey, we managed to run liquid nitrogen on it, and isn't it amazing how a smartphone can use 20 watts of power? Yeah, it can use. It's designed to use 20 watts of power. Very briefly, if you're seeing sustained 20 watts in real world use in a real world environment, then something's wrong with the firmware and the cooling. So we started to do this at Anantech back in the day. Is we'd do normal temperature runs and then freezer temperature runs. Are you back? Are you here to? Yes.
I'm more making the point that we are seeing sort of an increase, sort of a return. I guess my fear is more of a return to the Snapdragon 810 days, which I hope doesn't happen.
That was a problem due to TSMC 20 nanometer.
Sure, but but that could in theory happen again.
Well, you'd see it on the device. You don't see it by using liquid nitrogen cooling.
I agreed. If I remember correctly, that video was more about looking at extrapolating SDXE2 performance.
Yeah.
Which, yeah.
It's so. Just
going
back
makes
to
a good point here. Is the graph, because he actually shows a full graph, and how does the device perform in the realistic target of realistically your SoC burning about 6 watts, because you're really not going to cool more than that in this, right?
You might have an iPhone Air, and you would be cooling more than 3, maybe.
But still, my point is, you can only do so much with physics here, right? Physics is your limitation here.
Well, taking a couple of steps back here, so the new phone chip is the 8 Elite Gen5. It is a 2+6 design. With they call it 2 prime cores and 6 performance cores, but in reality, these are Oryon large and Oryon medium cores. And they during the tech summit here, it took me 20
Not
minutes.
economy cores.
It took me 20 minutes speaking to an engineer here to understand that the prime and the performance are actually different designs.
This is more like Intel P and E cores in that respect, or C1 Ultra and C1 Pro, rather than Zen 5 and Zen 5C.
Well, the Zen difference is just the L2 cache. In this,
no, it's not even the L2 cache.
But I mean, it's it's the
L3 per core notionally.
Yeah, no, but this isn't like P and E, because P and E also they have a fundamentally different approach to each other. The way it's described to me is this is more of a scaled architecture. So this is more like Oryon, Ascalon 8 wide versus Ascalon 6 wide versus Ascalon 4 wide.
Yes.
Let's see if I get the right picture this time.
That's the wrong one.
It's because the previews
there we go.
Are screwed.
So
right.
Do not mistake these for Intel's P&E cores. I was just using that as sort of what the wider audience would recognize as these are two different cores, right? These are not like what AMD is doing with Zen and Zen C.
They're ISA equivalent.
Yep.
Microarchitecturally similar, but scaled. Yeah.
So funnily enough, unlike Qualcomm's Cryo cores of yesteryear, back in the 820 and 821, which were identical except for the L2 cache, this are two different core designs, or core microarchitectures, I should say. So as we can see, Oryon large is a 9 wide design.
Oryon.
Dang it.
You keep saying Oryon like
Oryon.
You keep saying Oryon like NVIDIA Oryon.
I know, but it's not spelled like Oryon. Oryon, L, is a 9 wide design with honestly, to me, in my opinion, this is actually a better balanced core in terms of the structure sizes at a 30,000 foot level than what we saw with C1 Ultra, in my opinion. Right? Granted, I'm just some schmuck on the internet, so what do I actually know? But so
the large cores here are designed to hit 4.6.
In the smartphone.
In the smartphone, the medium cores here are meant to hit 3.6. Again, peak. But the gen on gen, they're claiming 20% overall better performance or 35% better power. They're both 3 nanometer chips, but this is obviously the latest 3 nanometer.
I believe
design.
They did say that is N3P. By the way, if you see claims of N3X, I believe that is incorrect. Qualcomm, the person at Qualcomm who said that, I believe, mixed up FinFET with different, FlexFin or
no,
FinFET.
that was so because I saw Andreas from Hardware Lux post that. Andreas wasn't at the event.
That actually came directly from a Qualcomm SVP. Hold on, where is it?
It wasn't said at the event though. At least not that I ever heard.
So computer-based translate To achieve this clock frequency, the company relies on TSMC manufacturing process N3X for selected cores. This was confirmed by Madhar Dirishpanani. I do apologize for if I mispronounced your name because I absolutely butchered it. Senior Director of Product Management at Qualcomm in an interview with Computer Base. For the X2 Elite family, Qualcomm primarily...
Who wrote that article?
Nicholas LaRucco.
Oh, yeah. Nick was there. Yeah, I saw Nick. Mania... that's who I spoke to understand that these were two different cores. He was the one I spoke to for 20 minutes.
So to understand the quote is, all the products we announced yesterday are built predominantly on N3P, but we have made the opportunistic choices using N3X transistors to get the benefit of higher speeds wherever possible. This
that is confusing.
This sounds like FinFlex, which what FinFlex is you have an option of fin count. I don't quite understand the full details, but your standard FinFET is 2, 2, and 2. You can have the option of 2 and 1 or 2 and 3, or sorry, 3 and 2. I believe what this is referring to is using 3, 2 transistors in the Oryon L core.
Push frequency, yes.
Yes. Yeah. Not using N3X. I believe that is a miscommunication there.
But it's the latest version of N3P.
Yes.
Because as always, these processes got optimized over time.
And actually sort of not ragging, but sort of, I think a major missed marketing point for Qualcomm, in my opinion, was actually the GPU, which they're claiming is 2.3 times faster than the prior SDXE Elite in SDXE2.
Hang on, we're still talking about mobile chip. Let's keep focusing on mobile chip for now.
Okay. Because I was effectively done with the mobile chip because there's.
Well, the mobile chip, they're claiming 23% fast GPU, 20% or 20% more efficient, and they've improved the ray tracing capabilities. I was asking about the GPU in the compute platform, and the person turned around to me and said, "Oh no, you're getting that confused with the mobile platform." And I'm like, "No, I'm not, because there was some confusion about what was the Adreno GPU in each of the platforms, because there's some interesting stuff going on in the notebook chip. On the NPU, they're claiming, is it 30% faster in certain tasks on the NPU?
It's 78% because it's 80 top. Oh, wait, no, sorry. This is the mobile chip. Even I'm getting confused.
This is what I mean. They should. The reason why there's confusion is because they did mobile and compute benchmarking on day 1, and then the announcement was in day 2, but both of them have been joined together at both instances. So you got to remember that these specs are for this part and these specs are for that part if you want to speak about both. The big NPU thing is support for int2.
Yes, into an FP8.
They didn't say which versions of FP8.
I'm going to assume that they're supporting what is it? E5.
Oh, 5.3, sorry.
E5M2 and E4M3.
I think it's only one of those because it's specifically for inference. That being said, they were talking about on-device training as well. And because MediaTek did this as well with their MNT 9500. It turns out what they're doing is a LoRa, a low-ranked adaptation thing. Okay. So it's you can manipulate certain values in one of the layers without needing to do backprop.
Yeah.
Or you can just code prompt with a database of preferences. And that's like training as well. Consumes more power, but yeah. They had a couple of demos on smartphones showing. So they actually had the GPT OSS 20 billion parameter model running on devices. On that, I believe that was only operating in CPU mode, but they had Llama 3, 3 billion, Qwen 3, a variety of those, all NPU. And their goal now is to essentially say, well, all the open source models, we want to make sure that there's an NPU version such that if the people want to go and refine it and do some further fine tuning, they can, or they can do this sort of code prompt or LoRa type stuff. But yeah, smartphone chip coming soon.
Moving on
already
to
here in China.
Yeah, already here in China. Moving on to the STXE2, the laptop chip, which is more exciting for me personally because that's one, easier to test, and two, easier to access. Like when that comes to market, which you're estimating is going to be H1 26.
Yeah, usually with these things, give it 6 months for devices. So CES.
Yeah, see, I expect devices to start showing up at CES. Yeah. The cores are now clocking all the way up to 5 gigahertz in the laptop part. I will admit I'm not a massive fan of this name. The Snapdragon X2 Elite Extreme
Edition.
Yeah. Well, no, there's no edition. I was joking that's going to be the X3. It's going to be the Snapdragon X3 Elite Extreme Edition.
X3.
I don't know what they're going to do for an X4 to add another E.
No. It's in the briefings they'll say, "Oh yes, this is the X2 Elite Extreme Edition." The edition isn't part of the formal SKU name, but it is what's being said colloquially.
So if I say X9, if I say X2 96 or just X96, this is the chip I'm referring to.
Right. So at a high level, Qualcomm announced 3 laptop SKUs. An 18-core with on-die memory. That's this. An 18-core without on-die memory with standard LPDDR4 on-package. Sorry, yeah. So there's an on-package version and an off-package version, and then there's also a 12-core with off-package memory. When the memory is in package, it is a 12-channel design, and these are mobile memory channels, so 16 bits.
So that's 192-bit total.
And with the memory they're using, that's good for 228 gigabytes per second memory bandwidth. The other ones without memory in package are only 8-channel, so they're binned down. They will hit 152 gigabytes per second. But the benefit of having on-package memory, and we tackled this with Lunar Lake as well, is that you can actually reduce the memory controller by 100 millivolts or 200 millivolts, and that saves power. That being said, it's a bit more expensive. Qualcomm essentially has to sell the chip with memory, and then it has to decide whether it's going to have a margin for that memory.
And honestly,
as well.
I still question how much power you're actually saving, because you're saving, if I remember correctly, approximately 40% of the memory PHY power, which I doubt is more than saving maybe a watt.
Well, so if you're transferring models in and out of memory, you could be consuming a lot.
Yeah, I guess
over time, and the way these models are skewed in terms of naming is the high-end model is 96,
Mm-hmm.
the mid model is 88, and the
Mhm.
low model is 80.
Yep.
So it's X2E, then those two digits, then 100.
Yep.
Yes, it's really hard to think about. So there's like a 18 core premium, an
Mhm.
18 core and a 12 core.
Yep.
So
Now,
all three of them have these L cores and M cores.
Mhm.
It's three. So in silicon, it's 3 slices
Mhm.
of 4 plus 2 in each slice.
So 4 prime cores and then 2
No,
premium
sorry.
cores.
No, sorry. So there's two slices of L cores and one slice of M cores, and the 12 core just takes out one of those slices.
Okay.
So it's 12 plus 6,
Mhm.
12 plus 6, and 6 plus 6. The top model has 53 megabytes of cache. The other two models have 34.
No, the top 2 has 53 megabytes of cache.
Oh, but the memory, the memory stays down.
Yeah, the memory. So the memory on the 96 is 192-bit. The memory on the 88 and 80 is 128-bit.
Yeah, we
However,
said that.
the 88 has the same amount of cache, 53 megabytes, as the 96. However, because of the cut down cluster, the 80 only has, I believe it's 34 megabytes.
34,
cache.
Yeah. It's and there are frequency differences between the three. The only one that hits 5 gigahertz is the one on the screen.
Yep.
The 96.
And I believe somebody in chat earlier, I cannot say your name. I can say your middle name, Pedro. I don't know how to pronounce your first. I do apologize. My eyeballs tell me that it's somewhere in the 200 to 230 range, not the nearly 300 that Andreas was getting.
You're talking about die size in square millimeters, just
yes,
so
I'm
people
talking about the die size of the chip. My eyes gauge it at about 200 to 230. Not the nearly 300 that Andreas got.
So let's see if I can get the right picture here. And these are out. No. I thought I had a different image here, but I clearly don't. So they provided some small benchmarking numbers on this, but we're going to have to wait for the full benchmark suite.
So they did provide.
That's what I wanted to say. This the big model here, this one, memory starts at 48 gigabytes.
This was weird.
It supports 128 plus. So if there's going to be a SKU with 192 gigs of memory for AI, maybe at some point, that would be insane. The other two versions where you don't have on package memory will only go up to 128 in max config. I'm not sure whether this is Qualcomm talking about what OEMs will do, or just saying, hey, it's up to them, whatever they want to do, which isn't very Qualcomm-like. So,
hold on, I'm trying to get that.
Yeah. All three chips have 12 lanes of PCIe 5, which is 2 lots of storage and 4 other lanes for something else. 4 lanes of PCIe 4, up to 3 ports of USB 4 at 40 gig, 3 displays at 4K 144, and AV1 encode decode. And this is the GPU that they were saying had 2.3 times increase in performance per watt.
if you check the Take Routine DMs, I believe that's what you're trying to pull out. But yeah. So basically, if
yeah, I can't confirm or deny that. So that's yeah. What you're trying to show me there is technically under embargo, so I'm not going to show it. Yeah.
Yeah, how that got out.
That's why I asked you in the chat. Where did you find it?
I think it was from somewhere. I think it was from a Chinese site. If I had to take it, Chinese or Japanese.
Yeah, as always, hard to put through the leaks. Yeah. So the GPUs run at 1.2 gigahertz, will turbo up to 1.7 or 1.8. And I think a big thing here that was kind of missed is that now the GPUs are fully DirectX 12.2 Ultimate compliant.
Yes.
In the last generation, they were DirectX 12, but not the full Ultimate spec, and now they are. They also said that they successfully have got some forms of anti-cheat working, so you're able to play Fortnite now. There's still a couple more to go in terms of the compatibility layer that's needed, but it's there. They also have a new feature called Guardian, which is their equivalent of vPro fleet management, and that will be coming to business devices next year.
What I will say, what I'm curious about is the power in multi-threaded tasks.
Yeah, that's stuff I can't talk about, unfortunately.
They showed 65 watts on the slides during the live stream. Whether it does 65 or does more or less, TBD.
Yeah, we're gonna the smartphones are ready to go now. The notebooks are to come.
Yep.
And we have some.
By the way, I have booked for CES, so I'll be there.
Cool. Lisa has just been announced. AMD's got a keynote.
Yep.
I expect Qualcomm will have a keynote. So.
Yeah, Lisa's the starring keynote, if you will.
Yeah.
So I was gonna say, if you want to do the spiel and then move on to the boxers.
No.
Aw.
Trying to find views that'll play ball because I haven't had nearly enough. Hey.
Aw. Kitty cat.
I'm being hissed at.
No.
Not by that one. Hey.
You went for a ginger cat.
No, there's one under the table that's hissing. Hey. Those are fluffy.
Fluffers.
Ooh. The wind is picking some stuff up, so it's making them jump. Hey. Meow. I'm hearing another one somewhere. Yeah. Well, with that, we've actually hit an hour. With the two major topics. I mean, we haven't covered Apple. Has now done A19 and A19 Pro. We've got an article up on More Than More to share that, and other things like TSMC's optical now has more customers with IR Labs. Tens Torrent did an announcement on their CPU productization, which is pretty cool. And then also iPhone Air can apparently even hold to 100 kilos.
200 pounds, about 100 kilos.
Yeah, 200 pounds isn't 98 kilos.
No, that's wrong, but yeah.
Yeah.
Close enough.
Yeah.
Autofocus eyeglasses. Interesting. Anyway, so that's
Meta announced new Ray-Ban things as well. There was some of that going on. And
also,
funny enough, I won the Formula One Challenge, Qualcomm's Formula One Challenge here.
Did you?
So they, as part of this, it's like let's do some demos based on the new chips, and one of them was Assetto Corsa. So they got a company with a couple of simulators, right? Running Snapdragon, and because Qualcomm sponsors Mercedes, they had Valtteri Bottas, the backup driver for Mercedes teams, on site. So I got a selfie with him. Nice. He drove. So they set the cars up in the high downforce spec on a dry Monza, with all the driver aids turned on except for user acceleration help. Valtteri did a 125 something. I did a 128 something. The nearest person on site did a 130.9.
Nice.
So I was pretty much closer to Valtteri than almost everybody else at the event who had a go. My prize was a signed Mercedes baseball cap from Valtteri. He's going to Cadillac in a few months.
Yep.
So that was Valtteri got 10 laps. I only got 1. So there is that.
Also, high yield. If you're still here, both Ian and I will be in Phoenix. However, do note that there is a ground stop still in effect for Phoenix Airport due to thunderstorms in the area.
Yeah, I'm flying out at 7 o'clock tomorrow morning to go there.
Yeah, currently that ground stop is in effect until 4:30 p.m. local time, which is an hour. It was about 80 minutes. It's still in effect.
Is Arizona Pacific?
Yes.
Okay. Yeah. There's some more cats moving around. It's very warm today. They're all hiding and sleeping. So
yep.
I've got a brand new camera, so I'm going to be taking lots of photos.
Nice.
Cool.
So
I'm going to head out and have some lunch and spend some more time.
I think you need to take some Benadryl.
I don't know.
Yeah, I think you need some antihistamines there.
I don't have any with me. There's
wait, is Arizona? I could have sworn Phoenix is. Hold on.
Yeah, no, I've missed a flight in Phoenix before, so yes, it is 1 hour difference. It's mountain time.
Nope, it's okay. It is mountain time, but because of DST, it's the same time as here.
Okay.
So currently the time does not change. For me, at least.
Yeah, Arizona doesn't do the daylight savings. So, all right, then. I'm gonna love you and leave you all. And if we get time, George and I might be able to do something more in a couple of days.
Hopefully so.
We'll see. Take care, everyone.
Have a good one.
If you like this content, there are multiple ways to support the channel. You can like and subscribe this video, and many thanks for doing so. There's also Patreon, which gives you access to our Discord. There's a merchandise store and a newsletter, links in the description. For all of you who do contribute, thank you. You are keeping me well fed.